Good afternoon, and welcome to the CAE Associates ANSYS e-learning series. My name is Reni Raju, and today I'm going to talk about how to generate inflation layers using ANSYS Workbench for CFD applications. A couple of things. You're all muted on entry, so if you have any questions, please feel free to submit to the chat window, and I'll try to answer the questions at the end of the session. If I'm unable to do so, I'll try to follow it up through email. And this webinar is also being recorded, so it will be posted in the future on our website, so you can use it as a reference later on. In addition to that, if you're a resident of New York or New Jersey, you can receive continuing education credit for attending the full live webinar and participating in the polls, and finally completing a survey at the end of the webinar. You can also visit our website for further details. We have more e-learning topics coming up in the future. The next one is submodeling in ANSYS Workbench 14.5. Right, so just a brief agenda of what I'm going to talk about today. I'm going to give you an overview of the different type of inflation controls, both global and local, in order to generate inflation layers for CFD. And in addition to that, I'm going to talk about the different type of inflation options that are available in the workbench, and follow it up with a live demo where I'll walk you through the different type of controls, both global and local. Before we talk about how you can generate inflation layers, let's talk about why do you really need inflation layers. If you are a person who has worked in the area of CFD, you must be familiar that how important boundary layer is for CFD calculations. Consider, for example, a flat plate that is sitting in a free stream. Now, as the fluid comes in contact with the flat plate, it will deaccelerate. In turn, due to this deacceleration, there is a development of a boundary layer on top of the flat plate, which could be either laminar or turbulent, depending on the Reynolds number. What essentially happens over here is that due to the fluid deacceleration, there's a gradient gradient of the velocities that are seen in the boundary layer, which looks something like this. Now, if you are working with a conjugate heat transfer problem, due to the temperature difference between the flat plate and that of the free stream, a thermal boundary layer also might be seen. So, in order to get accurate results, you need to resolve this boundary layer using inflation layers. What happens in case you are not resolving these boundary layers correctly, it could lead to incorrect physics. You could over or underpredict drag, lift, separation, reattachment, turbulence characteristics might be off, or other losses on the surface such as friction losses might not be varied correctly. So it's really crucial that you do resolve your boundary layer in your calculations. By this time, I'm assuming that you're familiar with the Workbench interface. This is how the meshing interface looks like. You have the model, and in that you have the mesh subtree. If you click on the mesh subtree, a panel pops up at the bottom which shows you the different type of controls associated with the mesher. These are the global controls, and one of them is the inflation control. So globally, when you apply inflation, it is called as automatic inflation. I'm going to walk you through the different types of inflation options available with the global controls. Now, when you apply automatic inflation, 3D inflation layer is generated on all the parts and bodies within the model. Note that here the inflation layer generation is 3D in nature. You have several options in order to control the automatic inflation. The default option is none, which is available as a drop-down menu when you click on the automatic inflation. So if you have the option set to none, inflation layer is not generated on any of the bodies. The only way to do that would be using local mesh controls. The second option is to use program control. When you select the program control options, all the fluid bodies in the model will be inflated. The solid bodies will be ignored, and the way the program control works is it chooses those phases which meet a certain criteria. For example, if you have chosen a phase which is within a name selection, and if it has been excluded from the program control option, it will not be inflated. So is the case if it belongs to a contact region. Now, the contact region between two bodies usually is assumed to give a flow-through mesh, so it won't generate an inflation layer on that. Similar is the case if you're having a symmetry definition or if you have sheet bodies. Also, if you're using a sweep method on any of the bodies, inflation layer won't be generated on that. If you also specify manual inflation controls of any of the bodies, those will also be ignored during the program control inflation layer generation. The third option is to use name selection. If you use name selection, then only those faces which belong to that name selection will be inflated and the rest of the faces will be ignored. Here, you can only choose one name selection. How do you apply these inflation controls in the global setting? So, like I mentioned earlier, you just choose the automatic inflation method. It could be program control or the name selection, and based on that, you need to select an inflation option. There are 5 different types of inflation options, and we are going to discuss that more in detail. And depending on the inflation option chosen, you need to select either the transition ratio, the total thickness, the first layer height, or the first aspect ratio. In addition to that, you specify the maximum number of layers you want in your inflation layer, which by default is 5, and it can go as high as 1,000. The third option needs to be specified is the growth rate or the aspect ratio, depending on the inflation option you have chosen. In addition to specifying the global inflation controls, you can also specify local inflation controls. And the way it works is that it is available as a subtree of the mesh tree. So similar to the way you insert a method for a given body, you can insert the inflation. When you do so, another pattern pops up at the bottom, which allows you to scope the geometry, which could be a body or a face, and the boundary, which could be a face or an edge. So if you use local inflation, it has several advantages, especially if you're working with a complex geometry. For example, this is a case where I apply inflation only on a surface of interest. I choose this surface and I apply local inflation over here. Note that the inflation is generated while the rest of the surfaces are completely ignored. Now, if I have a complex geometry and if I want to apply individual controls on these faces, because using a single control might not be really helpful, it is really beneficial for me to use this method. This supports both 2D and 3D inflation layer generation. And if you look at the options with the local controls, they are very similar to what is available with global controls. You have similar inflation option, the transition ratio, because I'm using smooth transition over here, the maximum number of layers, and the growth rate. Right, before I move on, I want to do a quick poll just to get a feel of what is the difficulty you have when you're generating inflation layers. I'm going to open up the poll. Is it because of dirty CAD, complex geometry, or because you're not really familiar with all the options, or just because you have not used inflation layers in the past? I'm going to give you a minute to complete the poll for everyone. Just a few more seconds over here. I'll just let everyone complete the poll. It looks like most of you are actually dealing with a complex geometry, and that's the reason why you have difficulty generating inflation layers. All right, let's go back to our presentation. Let me talk about the different inflation options that are available to me when I'm using ANSYS Workbench. So in general, The total number of inflation options available are then there are essentially 5, and these are available as a drop-down menu when you click on the inflation option. The first 3 are common for all the methods, regardless of if you are using hex or death mesh methods. And if you are using patch conforming methods, the last 2, which is based on the aspect ratio, are also visible. Let's try to go through each one of these options and understand what they are doing. The default option is to use smooth transition. When you use the transition rate, here you define a transition ratio, and based on the local tetrahedral size, it computes the local initial height and the total height of the inflation layer, such that the rate of volume change is smooth. Note that this is really dependent on the local surface mesh size. If you have a uniform surface mesh size, the thickness of the inflation layer that is generated is going to be uniform. However, if you have a surface mesh which is non-uniform, such as the case over here, you will see that the inflation layer thickness might actually change based on the local surface mesh size. On the other hand, if you want a constant thickness, you can use the total thickness option. Here, you specify the total thickness of the layer, and based on the growth rate, the inflation layer will be generated. And the inflation layer will look something like this. On the other hand, if you want more control and you have an idea of how much should be the first layer height, instead of specifying the total thickness, you can specify the first layer height. And since the growth rate is defined and it's constant, the adjacent layer thickness also becomes constant. So you will end up with the inflation layer which is more or less of a constant thickness. If you're using a death mesh method, such as the patch conforming method, you will have 2 more options available to you, which are based on the aspect ratio. Now, the aspect ratio here is defined as the ratio of the local inflation layer base size to the inflation layer height. And this could be the first aspect ratio, or you can use the last aspect ratio. When you use the last aspect ratio, you also have to define the first layer height. So what it essentially does is calculates based on the defined last aspect ratio the height of the last present cell, and the rest of the inflation layer is filled in. Note that for all the options available, the number of layers and the growth rate are common, except for the last one, which is the last aspect ratio. Here you don't define the growth rate. Instead, you define just the last aspect ratio. All right, so what I'm going to do is take an example and try to walk you through the different global and local controls. If you have attended one of our past webinars, you must be familiar with this particular geometry, where we have talked about the different meshing methods that can be applied for CFD. So this is a ball joint valve, and you can see there's 2 pipes, and the valve is in the center. And the flow domain that has been constructed consists of 3 parts. There are 2 cylinders, and the one in the middle is a little bit complicated, so it makes it interesting for our purposes. So you can see there's an inclined pipe, and there are these corners and rounds over here. So what we're going to do is generate a mesh on this and inflate so that we can use it for our CFD calculations. This is how the original mesh will look like if I decided to apply different methods on that. So since there are 2 cylinders, I can use either the hex mesh method or a death mesh method. So I find the cylinders to be sweepable. So for the first cylinder, I'm going to use a sweep method. And for the second cylinder, I'm going to use a multizone method. So both the first 2 methods are based on hex mesh. And the center body is not sweepable. So for this, I'm going to use a patch conforming method. So once I do that, you'll see this is how the mesh looks like. I can take a section in the middle and take a look in detail how the mesh looks like in the center. And you can see hex meshes for both sweep and multizone, and the center body has a death mesh. But this is not really useful for our CFD calculations because I don't have an inflation layer. So any results I get won't be correct. So what I want to do is generate an inflation layer on all these faces, which are the walls, and see if I can use it for my CFD calculations. So in order to simplify, what I'm going to do is first select the mid body where I'm going to display all the controls, and I'm going to suppress the rest too. and I'm going to come back to it when I finally generate, when I talk about the different mesh methods and how inflation is applied to that. All right, so this is the center body where which uses the patch confirming method. So if you click on the mesh, like I mentioned before, the panel that shows up shows all the mesh controls, and the default one says none, and that's how the mesh looked like when I generated it. So I'm going to use program control now, and I'm going to select that as the automatic inflation option. Once I do that, the mesh will be generated on all the faces of the body. Now, one great feature in ANSYS Workbench is that I can preview the mesh before I generate the final volume mesh. I can do that by right-clicking, saying preview, and I can say preview inflation. So what it does is that instead of generating the full volume mesh, it will first generate only the inflation layers, and I can get a feel of where the inflation layer is being generated, if it is good enough or it's accurate or not, if I need to change some parameters. And by doing so, I can say cut down on my meshing time. All right, so you can see there's a surface mesh that is generated, but if you take a section, you will see through the middle, you'll see that only the inflation layer volumes have been, only the inflation layer cells have been generated. So I can see there's a nice inflation layer. I use a default option of 5, so there are 5 inflation layers over here. But what I really wanted to do over here is construct a flow-through mesh. And here, these two faces also have been inflated, which I don't desire. Now, if you remember, I talked about how you can use name selections in order to control where the meshes will be generated. So let me just demonstrate that. So what I'm going to do is create name selection on all the faces for this particular part. I'm going to use box select all the faces first, and then I'm going to deselect these two, and I'm going to insert name selection and call this one the wall. I'm going to select this one and call this the inlet. I'm going to select this one, and I'm going to call this one the outlet. All right, so I have 3 name selections. Now, if I click on any of this name selection, you will see under the definition there is an option which says program control inflation, whether I could want to include or exclude this. So I choose to include this one, and for the inlet and the outlet, I choose to exclude them out. And that is what I desire for my final mesh. So I go back and I can right-click on the selected body and say generate mesh. Once I do that, I'm not previewing the mesh again because I kind of have an idea how the mesh will look like on the wall. And what it will do is it will generate the mesh by ignoring the inflation on these two faces because we excluded them out of the program control inflation. So you can see, if I take a section here again, you will see that I have generated the inflation layer the way I desired it to be, and the inlet and the outlet have been ignored for inflation layer generation. The second option to use is name selection. So I can choose all the faces in the name selection. Then you will have an additional option for name selection itself. So you can choose it to be wall. That's what I desire to generate the mesh. And this is what we defined earlier. And as you know, like the rest of the parameters remaining the same, if I was to regenerate the mesh, it will look exactly like this. So these two ways I can control where exactly I want to generate the mesh on this given part. Note that when I put in both my cylinders back in, these surfaces automatically will be ignored because they are contact regions. Right now, since we suppressed them, they are this part only has a single body. All right, so let's try to take a look at the different type of local controls. So in order to generate local controls, there are a couple of ways you can insert the inflation. You can right-click on the mesh, insert inflation. When you do so, you will have to select the geometry. Here I'm selecting this geometry, and I'm just going to say apply, and then I'm going to select the boundary. Since there's a lot of faces, I'm going to use name selection in order to define where I want to scope the inflation to. So I'm going to select the wall. You can see I've selected all these walls. And let's try to look at the different inflation options. So smooth transition, we already looked at how it, once it was applied in the global inflation. The two additional options here are total thickness. If I select total thickness, I can specify the total thickness of the inflation layer. And here is the maximum thickness 0.1. You can see once I specify 0.1, next to the cursor there is a circle which indicates to me what is going to be the size of this inflation layer compared to the rest of the geometry. If I change this parameter to 0.25, you can see that the circle becomes big. So it gives me an idea of how thick is related relative to the current geometry. If I choose, I can also specify the first layer thickness. And when I choose first layer thickness, here I need to specify the first layer height. I'm going to specify it to be 0.01. And again, the cursor gives me an idea of what is going to be the size of the first layer thickness compared to the rest of the inflation layer. What I'm going to do right now is going to generate the mesh with first layer thickness. That's usually my preferred method of generating meshes because it allows me more control. So once the mesh is generated, you will see that all the first layer thickness is maintained throughout most of the domain. Almost done, and here's the mesh using the first layer thickness. Looks very similar, but if you go and zoom in on any of the spots, you'll see that the first layer thickness is constant. I can toggle off the volume, and I can actually get a better view of how it looks like exactly in the section plane. One thing to note over here is that as it reaches a point where the faces are small or a sharp angle, the mesher itself will try to accommodate the number of layers by sometimes compressing the meshing layer. So in this case, you can see it in this corner, but for most part, it will try to maintain whatever options you have specified. You can look at the different location of the mesh using the section plane. I can just drag it through this and see how the mesh looks like at the different parts of the body. And if I feel that my mesh is not good enough in a certain region, I can go back and use different inflation options in order to control how the meshing will look like. So here, you don't necessarily need to specify a single inflation option for a given method. You can use multiple options. Let me show you how to do that. So here, I'm going to use, instead of name selection, I'm going to use geometry. I'm going to click on the geometry selection, and I'm going to deselect these two faces. And let me show you how to insert inflation using another method. Is that I can just click on the patch confirming method and say inflate this method. And when I do that, it will automatically scope the body, and all I need to do is select the geometry. Right, so I selected these two faces and the rest of the faces here. Now, instead of using first layer thickness for this one, patch confirming has two additional options, the first aspect ratio and the last aspect ratio. I'm going to use one of these options for this inflation control. I'm going to select first aspect ratio. The default value is 5. I'm just going to use that. And for these two faces, I'm going to use last aspect ratio. And I'm going to specify the first layer height of 0.01. Right, so let me go back and generate the mesh on the selected bodies again. So once I generate the mesh, as you note, I have used two completely different options in order to generate the inflation layer here. So the obvious question would be, is the mesh continuous between the two because I'm using two different options? The answer is yes. The mesher automatically will accommodate to to ensure that the mesh is always continuous between within the volume of this body. This is also true if you're using if all the bodies belong to the same part. It will also make sure that just the way the conformal mapping takes place at the contact regions, you will also have a continuous mesh for the inflation too. Right. So when I look at the section, this is how it looks like. And if I zoom in over here, note that here is where I applied the last aspect ratio, and here is where I applied the first aspect ratio. If I zoom in over here, the mesh is indeed continuous between these two methods. So using different inflation controls, I can change or modify the inflation layer mesh, and it helps me if I'm dealing with a complex geometry. All right, so with this, that's just a demo of how you apply the local and the global controls. I want to do a quick demo, quick poll again. For that, I'll just stop sharing the screen, and what I'm going to do here is bring up another poll, and then just want to find out how much of your total time do you spend in meshing. In meshing, you spent in generation of inflation layers. I'll just give it a minute for everyone to answer that question. A few more seconds over here. It looks like it's more or less even in terms of how much time you spend in generation of the mesh. Some of you spend a lot more than 50%. Hopefully, with an overview of what we are providing over here, it might help you a little bit more with reducing the amount of time you spend in generation of inflation layers. Let me go back to my presentation, and let me talk about the different type of methods and how inflation layer is applied on those. So far, all the methods we have seen in the demo too is applied on the patch conforming method. What happens if you change the method? If you use maybe say the sweep or the hex mesh method. So in this case, let me talk about those briefly over here. If you use the sweep method, you know that inflation. When you use the sweep method, you have essentially a source face and a target face through which the mesh is swept in order to generate the volume mesh. This could be specified automatically or using manual controls. In this case, you cannot scope the inflation layer to a surface. What you have to do is you need to select the source face as the geometry and the edges at the boundary. Once the source face has a mesh generator on that, it is swept through the volume in order to generate the final volume mesh. Note that because of this reason, the source and the target face cannot be inflated. So when you generate a mesh, it will look something like this. However, if you want to make sure that your source and target face also need to be also have inflation, you can opt for the multizone method. With the multizone method, the inflation can be scoped to the surface very much like the patch conforming method. In this case, both the source and the target face can be inflated, and you can see the example over here. Here, all the faces have been inflated based on the method I've chosen. So let me show you this example using the demo case we've been working on. So let me bring up the same geometry. So in this case, what I've done is that brought back the two cylinders where sweep and the multizone have been applied. So I'm going to go and select the sweep method, which is applied to one of the cylinders, I'm going to right-click and going to say inflate this method. When I do that, the geometry is automatically selected to be the face, and I can select the boundary to be the edge, and click on that, use the default options, and just going to right-click and generate mesh on the selected bodies. When I do that, it will sweep the mesh from the source to the target, and when I look at the mesh, this is how it looks like. And if I take a section of that, you can see that these edges, the surface of the cylinder has been inflated. Similarly, I can also create inflation on the using the multi-zone body. Again, I'm going to right-click on this for this particular geometry and say inflate this method, and I'm going to apply on the surface using the default options again. I'm going to right-click and say generate mesh on the selected bodies. All right, so if I take a section again here, you can see I'll toggle on the volumes cells, and you can see that in both cases I have a hex mesh, which is a nice inflation layer that is generated. So I'm going to go back and I'm going to recreate my mesh on my mid body. So one thing to note over here is that the meshing order sometimes is also really important. It depends on how you generate mesh in a certain order. This has been demoed in the past webinar. In this case, since I'm generating the first two, the hex meshes, the faces have chord mesh, and that's what is borrowed when it's generating the mid-body mesh. All right, so the mesh has been generated for all the three bodies. If I take a section over here, and I'm just going to zoom in, you can see within the multi-body, even though I'm using different inflation options, the mesh is always continuous through the body. So this shows how you can generate a multi-body inflation. Now, before this is all set to continue with our CFD calculations, but before I do that, I want to make sure that my mesh quality is good enough. So what I'm going to do is look at the statistics, so which is available through the mesh. If I click on that, I can click on the statistics, and I can choose a mesh metric which I want to investigate. I can choose the element quality, orthogonal quality, or the skewness. Let's take a look at the skewness. If I look at the skewness, you can see that the maximum skewness is 0.9. Usually skewness higher than 0.9 is not desired for your calculations. You want to make sure that your skewness is always below a 0.9, because if you have a highly skewed mesh, it might lead to errors and also problems with convergence. So I can go and take a look at where these highly skewed meshes are. So I click on the mesh metrics. I can click on the controls. And if I scroll down, I can choose the x-axis, which shows the skewness going from 0.9 to 0.91. And I can reset the axis, y-axis, which shows the number of cells to be reset based on how much are available. So if I see these are the number of cells which are having a higher skewness higher than 0.9. So if I click on those bars or columns, you will see that I can identify at which locations do I have this highly skewed meshes. You can see these three locations have this highly skewed. So in order to make sure that the meshes are corrected, I can go back and I can try to specify, use maybe a different inflation control, maybe use a local control, also specify different phase sizes, because the mesh is clearly dependent on, the inflation layer is dependent on the surface mesh size. And if I change that, I'll be able to modify and control the skewness factor over here. So let me talk about just briefly about, or give you an overview of what to look for in a mesh quality. Once you finish generation of your mesh, you should always ensure that your skewness and element quality are within a tolerable range. And if you have sharp corners or small faces, it can lead to bad mesh elements. So you need to make sure that these don't, you need to focus on those areas to make sure that you don't have highly skewed elements over there. In certain cases where you're having a complex geometry, where you run into problems like this, I would prefer to use local inflation over automatic inflation because it allows me to use multiple inflation layer definitions in order to modify these faces, and I can focus only on those regions of interest where I want to modify the mesh. If you improve your surface mesh quality, it will definitely help you with improving your overall quality of your mesh. So finally, in summary, we have talked about how important the inflation layers are for CFD applications. There are several options which are available in ANSYS meshing for generating these high fidelity inflation layers. And if you have complex geometries, preferably use local inflation controls because it will definitely help you in getting rid of those highly skewed meshes